to the next presenter. Thank you very much, Diego. Very comprehensive view of what's to come. And we move then to Vassilios Spathopoulos, who is going to present to us hands-on history of astronomy, ancient instruments in public outreach. That's also going to be a very nice change, moving to a new reality. So maybe, Diego, you can stop sharing your screen so that the next speaker can open the screen.
I'm not sharing anymore. I don't know if you still are watching the screen.
Oh, maybe I'm having problems here.
Yeah, the screen is still there. Will I try sharing mine or?
Yeah, just try maybe.
Yeah, let me try.
Yeah.
Did it work?
I think it worked. Yes, I think so.
Okay. Okay. Okay, so everyone can hear me and see me all right, I guess?
Yes.
Good. Well, thank you very much, Rosa and the organizers, for inviting me again to participate at this wonderful conference. I think it's my 4th time already, and I enjoy it every time. It's one of my favorite conferences, I have to admit. So my name is Vassilios. There were some excellent presentations, really impressive already. I do most of my astronomy outreach on my own, or I should really say with the help of my wife, who's a much more practical person than myself. So it might be a little bit more basic, but hopefully you'll find it also interesting. Right. So just very briefly to introduce myself, I won't bore you too much. My background is actually in aeronautical engineering. I worked in the past at universities in Greece and in Scotland. I'm a Greek Scot, that's why I have a Greek name and a bit of a Scottish accent. I currently teach at Glasgow International College, which is affiliated to the University of Glasgow here in Scotland. And over the last decade or so, I've developed a great interest in astronomy, especially the cultural and historical aspects of it, I should say. So I'm a fellow of the Royal Astronomical Society. I also tutor at the Edinburgh Council Adult Education Programme. I teach curious adults there, and I perform astronomy outreach at schools and science festivals. I've received funding from various organisations such as the Institute of Physics here in the UK and the Royal Astronomical Society. This is me at a science festival somewhere in Scotland 2-3 years ago. Here you can see me. The picture to the left is I'm at a school somewhere on an island in the very north of Scotland. This is August, by the way. You see how I'm dressed. But a month later, in September, I'm wearing shorts and t-shirt. I'm in a very remote Greek island. This is my record, I think. This school only had 3 pupils. And I'm presenting, you can maybe see at the top there, that's a fragment of the Antikythera mechanism. I once did a workshop at this conference, I think a couple of years ago, talking about that very interesting object. I'll be mentioning it further down in my presentation. So just a little bit of an introduction. With my outreach, I try and combine science, astronomy, of course, with culture, with art, and with history. So I try to bring in some interesting stories from the history of science, from the history of astronomy. As I mentioned, I do this at schools, at science festivals. What's, I think, key in this particular aspect of my outreach I'm going to be talking about is that I've tried with this work to engage a diverse audience with hands-on experiences. So I've acquired over the years various models of astronomical instruments or artifacts, replicas, or do-it-yourself projects that myself and I said, with the help of my wife, I have developed. So it's using hands-on models for doing this outreach. And this is a recent workshop that I did, and I'll use this as an example of what I'm trying to talk about. This was in a museum in a small town on a Scottish island, Orkney, and you can see that the title of the workshop was Astronomy Through the Ages, and I tried in about half an hour to briefly go through the various stages of astronomy development, but using these models that I'm talking about. So you can see some of them lying on this table. I'll be going through them one by one, but there's a replica of Galileo's telescope, there's a model of the Antikythera mechanism, there's a star compass, there's an astrolabe, there's a medieval navigation or timekeeping, if you like, instrument. And this is the idea. So as I said, I'll talk through the workshop with you, and I start off by telling my audience to imagine that the very first stargazers, probably the first humans that walked on this planet, gazing at the stars. I talked to them a little bit about the first sort of speculative evidence that there is of a depiction of the sky in art. That's the cave art in the Lascaux caves in southwestern France. Of course, I mentioned Stonehenge, various monuments all around the world that are aligned to astronomical events. But what I'm using here as my hands-on instrument, if you like, or artifact in this case, is what's known as the Nebra Sky Disk. I acquired this quite cheaply off the internet. It's obviously a replica. And this is the oldest known portable celestial depiction. It's been dated to around 1600 BC. Some of you will have seen this before. It's a bronze disc with some golden symbols, which seem to depict a crescent moon, the sun possibly, or a full moon, stars, and there's a group of 7 stars which may be the Pleiades star cluster. It was possibly used as a calendar as well, so I mentioned this to my audience. I then go on to the next stage, and I talk about the sort of practical applications of astronomy in antiquity. It was used for timekeeping. Stars and constellations were used for timekeeping. They were used as calendars. I introduced some ancient Greek poets who mentioned these particular aspects. And what I use here for this part of astronomical development is what's called a star compass. This is not a real compass. It's a mental construct that Polynesian navigators use. So basically, they memorize the rising and setting position of hundreds of stars. So if they see a star rising, for example, they know that at a particular latitude, the star Canopus rises from the southeast, let's say. As soon as they see the star rising, they know they can orient themselves. Another good tactic here is to link this to modern popular culture, such as the Disney film Moana. Some of you might be familiar with this. A Polynesian girl uses the stars to navigate back home to her island. So this is an example of something that you can easily construct yourself very cheaply, and it's a nice project as well for schools and for kids to develop for their particular latitude, find the rising and setting points of stars. And this is something that shows how astronomy of the stars was used for more practical applications, such as navigation. I then go on to the more scientific era. I talk about the Babylonians, who were probably the first culture to systematically observe their heavens. They meticulously took down their observations. They realized there were some patterns in eclipses, for example, the Saros cycle. You can use that to predict eclipses. And of course, at this stage, I have to speak about the ancient Greeks. I'm half Greek after all. Their contributions to astronomy. People are often amazed that 2,000 years ago, the Greeks did not only take for granted that the Earth is spherical, but they actually measured the circumference of the Earth. They measured the distance to the moon. They estimated the size of the moon. And what I use here to as a hands-on experience, if you like, is a model of the Antikythera mechanism. This was an ancient Greek analog computer, so to speak, that was fragments of which were found on an ancient shipwreck about 120 years ago. The shipwreck is dated to over 2,000 years ago. It was used for predicting astronomical positions, eclipses, and it demonstrates advanced engineering technology, which people are astonished with when they realized all the gears that were used, all the different dials, etc. And it's a good opportunity because it was constructed in the Hellenistic era. This is when Alexander the Great, after Alexander the Great conquered much of the region between what's now Greece and northern India, and the Greek culture got into direct contact with Babylonians, Indian culture, Egyptian culture. So it's a good opportunity to show people that this is how science progresses when there's a cultural exchange. This is my claim to fame, a clip from a Greek newspaper which interviewed me on a presentation that I did last year at a science festival in Scotland about the Antikythera mechanism. So I then move on to another stage of astronomical development. So I'm trying to go through the whole history of astronomy in about 20-30 minutes in these workshops. It sounds as if it's a bit overambitious, but it does work and it does help to have these devices with you. This era, of course, is sort of between the ancient Greeks, let's say, and the European scientific revolution. If you sort of follow the Eurocentric narrative, not much happened in those times, and this is what most of us learn at school, unfortunately. Of course, this is not correct. There were other parts of the world where astronomy and science flourished. For example, in India, in China, but most of all probably in the Arab and the Islamic world. We had the Islamic golden age during the Middle Ages. I tell my audience to think about words such as algebra, algorithm, all of Arabic origin, stars like Aldebaran, Vega, there's more than 200 stars that have Arabic names. And I highlight contributions of scholars such as Mariam al-Asturlabi. She's maybe relatively unknown, but she was known in those times as an expert astrolabe maker. So it's quite interesting that in those times a woman was involved in this. It kind of challenges some people's views of the role of women in the development of astronomy way back then. And the astrolabe, of course, is a magnificent instrument. If the Antikythera mechanism can be seen as an analog computer, I introduced this as a smartphone, the smartphone ancient and medieval times. It was actually invented by the ancient Greeks, but it was the Arabs who developed it often into an amazing work of art. And I've acquired a replica of a beautiful astrolabe, which I show people, and I try and explain a little bit how it works. This is probably the most expensive model that I have, but you know, we're still talking about $100, $150, that kind of price. The other instruments that I was showing, a lot of them are just model kits. They're much cheaper than this. For example, this one here, this is the final age I talk about. It's the age of the European scientific revolution. I try and explain to people that when the Europeans got into contact with the Arabs in places like Andalusia, in Palermo, in Sicily, for example, the Arabs had translated a lot of the Greek texts, and not only the Greek, Indian, Persians as well. And this is how the knowledge was preserved, basically. And then the Europeans translated the Arab text into Latin and sometimes into Greek. So it did the full circle, which is quite interesting. And this, of course, was also the time of European exploration. I try and explain again that a lot of the constellations in the southern sky, they were renamed by Europeans seeing them for the first time with names such as telescopium, for example, various other ones that relate to the age of scientific discoveries in Europe. But it was indigenous people that had their own lower star culture and names from millennia before the Europeans appeared. This is an instrument that is used for telling time. You basically use a circumpolar constellation such as the Big Bear to tell time, and it was used in medieval times. It's called a nocturnal, and again, it's a beautiful model kit, and I show people how this works. I also try and connect astronomy to literature. There's a quote from Shakespeare where he mentions the position of what we would call in Britain now the plough, or the Big Dipper, and in America has different names all around the world, of course. And he mentions how this is used for telling the time, which is essentially what this instrument does. And of course, most famously, this is what most people have heard of. I speak about the achievements of people that are much more well known, at least to Europeans. People like Galileo. I mention his revolutionary observations of the moon's surface, Jupiter's moons, the Galilean moons, the phases of Venus. I mentioned Copernicus, the heliocentric model, which had been proposed by an ancient Greek 2,000 years before, but it never became mainstream until Copernicus's time. And of course, Newton, who capped everything with his gravitational theory. This is a beautiful replica of Galileo's telescope, which, of course, you can see the real thing in Florence. But it's really interesting. You know, I take this to schools as well, and I tell people that it had the same magnification as a good pair of binoculars, and the field of view is so narrow. They look through it, and you can hardly see much at all. And yet, looking through this was revolutionary for the development of astronomy and
Vassilios,
science.
you have 2 more minutes.
Okay, thank you very much. Not much to go. So there's various things that I can talk about during these kind of presentations. Ancient structures I already mentioned, like Stonehenge, celestial alignments, the importance of astronomy in daily life across various cultures. Other cultural perspectives, for example, the diverse cultural interpretations of celestial objects and constellations. I talk about Sirius and the star Sirius, how important it was to ancient Egyptians. Arcturus, which in Hawaiian and Polynesian is called Hokulea. It means the star of joy because it's a zenith star for the latitude of Hawaii. When it's above your head, you basically know you're on the right latitude to return to Hawaii. And I try and emphasize the global contributions to astronomical knowledge. I already mentioned navigation and exploration, not just the European age of navigation and exploration, but also way back from the Polynesians who emigrated all around the Pacific Ocean, and the role this played in shaping world history. The evolution of astronomical thought, how we went from geocentric to heliocentric, the key figures, and emphasizing the collaborative nature of scientific progress. I also finish off always by connecting these ancient observations to modern space exploration, the fascination of humans with the cosmos, and the curiosity that it inspires about our place in the universe. Just to finish off, what are the benefits of such an approach? It's adapting presentations for different age groups and backgrounds, combining scientific facts with cultural stories always makes things a bit more interesting. And the fact that I'm using instruments, models of instruments, makes for a more memorable and creative, interactive experience. And of course, there's the general benefits of astronomy outreach, such as encouraging participation in citizen science and fostering appreciation for scientific wonder. That's it. Thank you very much for your attention. If you want any more information on the stuff I do, this is my personal website here, and I'm open to any questions and comments. Thank you very much.
Well, we are a little bit over time, but I will allow for this because we have one question here. Well, first of all, you have a comment. Being from Ireland, I am delighted to hear you mention New Grange, so
Yes.
special. And you have a question from David Souza. I am fascinated with the Antikythera mechanism. Are there modern replications?
Yes. The photo that you saw where I was holding a model, that is a modern replica that actually works. So it's amazing. I can set it. It's set to the modern era, and I can use it to predict eclipses that are happening at this time. So it can tell me when the next lunar eclipse will be, for example. So yeah, there are modern reconstructions of this amazing device.
Well, thank you very much. That was really, as usual, very inspiring to see the amazing things that you are sharing out there, and also to think how people used to think and navigate the unknown, which to us nowadays, it's all of this should be very well known and understood. Yet it's not, but it's really amazing and mind-boggling the things that were there at that time that you were showing and presenting to us. So thank you very much